experimentally by Steinmetz. This is the expression of the hysteresis losses. Now let's see the eddy current losses. Firstly, before see the eddy current losses, what do we mean by the eddy current? So, when the flux density change rapidly in the core, so according to the change of the flux, a small currents will get generated in the core, okay, on the surface of the core, as you see here, okay. As you see here, when we have a magnetic core, according to the variation of the flux density, a small current will get generated in the core. So let's go to the board. Okay. So when we have, this is the surface of the core. In case of when we have a flux intensity, density or flux variate on this core, a current will get generated in this core, and we call them eddy, which means شغل دوامة. Okay, so those currents are circular. Okay, have a circular path, and we call those eddy current, like this. So they are circular current that get induced on the core, on the surface of the core. So those currents we're gonna cause losses. So when the flux density change rapidly in the core, it induces opposing current called eddy current. And in other books, especially the French books, they call them Foucault current. Foucault, it's a name of a French electrical engineer or something like this. So they call them Foucault current, les courants Foucault, or we call them eddy currents. So when the flux density changes rapidly, in the core, it induced opposing current called eddy current that circulates within the core, as shown in the figure number 6a. So here you see this piece of the magnetic core, and you see those circulating currents that get induced in this core. So in order to reduce or decrease those eddy currents, we have to make a laminated core. What do we mean by laminated core? So we are not going to use the core as a single piece of the metal. Okay, so the core will be constructed from a compacted sheets. Okay, so this is the case A when we have eddy currents. So if we want to reduce the effect of the eddy current, this core must be divided into thin sheets like this. And between sheet and sheet, we have an isolation material. So if the core is composed by those compacted sheets, the current in these sheets get reduced like this. Okay, so let's choose another color. So this is the eddy current if we have small sheets. So in this case, we can reduce those currents because those sheets are isolated between each other with material. So in order to reduce the eddy currents, the magnetic core must be composed of a compacted sheets. So let's go back to the presentation. Let's go back to the presentation. So we can see here the time is running out. So okay, no problem. We're gonna We're gonna restart it again. So you can see here in this figure that the core is laminated. So it's composed by a compacted sheets, as you see here in this figure. So this one is the laminated core of the transformer. Those are the compacted sheets. Let's go to Google to see some pictures of laminated core. So you can, are you seeing here Google Chrome?
Yes, sir.
Yes.
Okay. So those are the compacted pieces that will be used to construct the core. So those one, the shape of E is for the transformer, like this. Okay. And those are of the electric machine. They are circular. Okay. Those are for the electric machine. So always the starter of the electric machine of the main core of the transformer is composed by those sheets in order to reduce the eddy currents. Okay. Also, the expression of the eddy current as eddy current losses as the hysteresis losses has been determined experimentally. Okay, so it's looks like the previous. It's equal to PE, which is the eddy current losses, equals to F equals to F times KE, which is the constant. Constant depend on the, okay, KE is a constant, depend on the type of material and the type and lamination thickness, and B max square. So also this expression has been determined experimentally. So now to conclude this, we have two types of losses that happened in the magnetic circuit. The eddy current losses, the expression of the hysteresis losses. The hysteresis, we said, is the phenomenon that happened in the magnetic circuit when we have an alternating power source or an time varying flux. Also the eddy currents, it's happened when we have time varying flux or magnetic field. The hysteresis losses pH equals to F square times KH, which is a constant, depends on the ferromagnetic material and the volume of the core, times B max to the power N. N is a constant, Steinmetz constant, which vary from 1.5 to 2.5, depending on the used material. Also, the eddy current losses, we said that the eddy current, the currents that get generated in the core because of the time varying flux, and in order to reduce those currents, we should construct our core from a compacted sheets. Okay, so the core, it's not a single piece, it's a compacted sheet. So we call this lamination. يعني كلمة lamination in Arabic means شغل مورق, as like the copybook. It's a compacted sheets. Okay, and the expression of the eddy current losses is equal to PE equal F times KE, which is the constant, depends on the type of the material and the lamination thickness, times B max square. So all these constants, this data should be given in case you have exercise or something like this.